Hi, I'm Nick Bonner for TreeStuff.com. We're here at the EDELRID World Headquarters and we're about to learn about how rope is shrunk, which is weird because usually people want to buy longer ropes. Martin, tell me why rope goes through a shrinking process.
Shrinking process is one of the most important steps we're doing over here, especially for dynamic ropes, because we were talking about the raw material. It's polyamide 6, which is roughly having an elongation about 25-ish%, depending on the material. But this is not enough for a dynamic rope, so we have to shrink the material to get more elongation into the material and in order to create a really dynamic climbing rope.
Interesting. What are we looking at here?
So we're looking here at the two components of a rope. So this is the core material, and over there we're seeing the sheath material. And also one reason why we're using polyamide is because polyamide does love water, and this does make the material shrinkable. So this is what we're doing over here in this machinery. Basically this is like a steam cooking pot your grandmother might have used. So this is what we're doing over here. So we're just steaming the material with hot steam, water steam, and this is making the material to shrink. In order to do that and to have it the same amount of shrinkage for all the material we're using, we have to create a structure within the textile that the steam can flow through very evenly. And so for the sheath, we have to do this step over here, which is a knitting process. And we need this process in order to have a structure where the steam can flow through the whole material, shrinking it even over the whole process.
So the question that immediately occurs to me is, that looks more like a scarf than rope. Rope's not large and flat like that. How does that material turn into rope?
Yeah, unfortunately, this step has to be done for the shrinking. And after the shrinking process, when we have the elongation in the material, we're just pulling the yarn out and then rewinding it to the carriers for the braiding machines, and this is done over there.
So a manual is the wrong word, a mechanical weaving process is done and then undone simply to facilitate a more even shrinking.
Yeah.
Looking at this is after and this is before.
True.
And you can feel the difference. This is a little softer and this is a little stiffer.
Yeah. You mentioned it, you can feel it, and actually you can see it. So before the shrinking process, the coils are more or less running to the bottom of this carrier wagon, and if you see it afterwards, we are shrinking it roughly around 20-30%, depending on the material, and you can quite quickly realize. And during the drop, actually in a more easy way of explanation, you can say what we're shrinking into the material. This is in combination with the elongation of the material, the 40% of elongation we get during a drop with a dynamic rope.
Wow. Is there a difference in the weight before or after?
Not really. So if you compare the weight of the whole coil, but if you compare the weight of, for example, a meter of twisted core, then for sure the weight would be higher due to the shrinking of the material.
When we look at this core here, there are 3 twists inside of here?
Yeah, so compared to the sheath material, what we're doing for the core, this is a double stage twist, so we have 2 twisting stages. If you look at this closely, the first twist is like the sheath material. So the material is twisted with itself 5 times, 6 times, 7 times, depending on the construction. And then this twist is used to twist it again in the opposite directions, in this case 3 times. So this is a 2-stage twist, so we call it.
Thank you so much for sharing how and why rope is shrunk for industrial and climbing applications. What's the next step?
The next step would either be, if we are talking about treated ropes, the treatment of the core material, or then setting up the material for the braiding machinery, so basically rewinding it on processable applications for the twisting process.
Okay, well, let's walk over and check out those steps then.
Yeah, sure.
Great.
Let's go. So in order to achieve the actual standard currently, so the UIAA dry treatment standard, we have to treat the core of the rope first, and this is what's going to be done over here. So treating textiles, it's always an uptake of chemistry and then trying to fix this chemistry by a temperature over time. And this is what's basically done over here. For every core strength first, then we're bringing it to the braiding machinery, braiding the rope around this already treated core, and then dipping the whole rope through the chemistry again and fixing this chemistry on the whole rope.
So my understanding with basically anything related to chemistry is that it's not so hard if you don't care about the environment.
True.
This is going to be something that we're going to touch on in some of our other videos and in our EDELRID webinar. You guys are not always taking the easy way.
No, we are not, and taking care of the environment, especially for dynamic climbing ropes. I mean, we all love nature. This is why we're doing the climbing,
right?
And so this is a big part of the deal, isn't it? Nonetheless, you have to say, technically, and this is how the treatment was done for years now, we still do use an FC chemistry, which is, if we only talk about technical aspects, water uptake, this is the best solution you can get. Nonetheless, you will mention it, we don't believe it to be the way to go for the future, so we committed ourselves to get rid of the FC treatment, and we're working on we already have an FC-free treatment, as we call it, eco-dry treatment, which is passing the standard as well, but you have to be aware that the downside of this is that it's not going to be as good over time. Nonetheless, we do think it's the way to go for the future.
And what is the requirement for the testing?
The requirement for the testing is, so first of all, within the test, you create abrasion to the rope, because like doing it with a new rope, it's rather easy. So the first part of the test is creating abrasion to the rope. And after this, the rope is put to a test, and you're flowing water by the rope, and you measure the weight before and after the test. And so the requirement you have to get is the gain of weight due to water uptake has to be less than 5%. Which is pretty tricky. So if you would use an untreated rope, you put it on the test, almost after 2 minutes you would have an uptake of 40-ish%, 50-ish% of water. Yes, polyamide does not uptake 50%, but the water sitting in between the core strengths will count as well. So this would be for a non-treated rope. So achieving less than 5% is pretty tricky, and this is why we have to start with the core strengths in itself to dye them first and then create the rope around it.
You mentioned that polyamide loves water,
yes,
and that's why we do these dry treatments on polyamide or nylon type products. Polyester, does it require the same type of hydrophobic treatment?
It would be good to treat it as well, but yes, this is one fact why polyester is used for application which are not that dynamic, or one of the reasons, and this is that the water uptake of polyester is way less than with polyamide. Nonetheless, treating polyester could be interesting for certain applications as well, where you know they are in contact with a lot of water.
Interesting. That 5% must be hard. I think if you hosed me down right now, I would weigh 5% more, just from what my clothes carry.
Yeah.
Martin, can you talk us through exactly what we're looking at here mechanically?
I can. So basically, in order to keep the process running the whole time, due to having temperature over here, the machinery can't stop. Due to the temperature is going to affect the material as soon as it stops within the machinery. So we have to have material here in order to change the running material in case this one is done, so to set up the next one. So this is just like basically storage of material. Then we have the dipping, so the uptake of the chemistry in here. And then as mentioned, what we're having over here is heat treatment over time. So this basically is just a temperature chamber. First of all, we're trying to evaporate the water within the solution, and then the fixation of the chemistry does start. And over here, we're just rewinding the material to get it into a way so we can process this on the braiding machinery afterwards.
So far, we've already seen so many steps where you're taking the material, assembling it, deassembling it. It must feel very repetitive sometimes, but it's really incredible how many things it goes through, and we're not even halfway through, it seems like.
And if you watch the layout of our production facility, this is what's going to happen. So the whole top floor over here is just like setting the material up in order to make the braiding downstairs. So you always think about rope production as the braiding, and this is a hugely important part. But the same amount of space we're using for the braiding is up here. We're using the same amount of getting the material ready for the braiding.
Martin, are you able to demonstrate the effect of this dry treatment for us?
Yeah, that's pretty easy.
Great, let's take a look. Martin, walk us through the effect of the dry treatment here as we can see it physically.
Yeah, pretty simple. So this is a non-treated polyamide. We said polyamide does love water. So if we just add a few drops of water over here, what you can see is basically not much because the polyamide is uptaking the water so quickly. Over here, we have a dry treated core material. And if we do the same thing over here, what you can see is, first of all, the water is staying on the surface, so the polyamide is not uptaking it. And if you just turn the material a little bit, the water quite quickly will run off. So this is the repellency effect we were trying to implement, and actually it did quite work out well, I would say.
Can you put those 3 drops back there for me?
Yeah.
Kale, come over here. I'm going to try to blow the water towards the camera. Okay, that was pretty cool. Can you give me like a line of, give me a line of water? That's pretty impressive.
It is.
Well done.
It is.
Martin, thank you so much for sharing with us and with our audience exactly how and why a rope might be treated against water. What's the next step in the rope production?
Unfortunately, we still need carriers for the braiding machine for the sheath material. So this would be the next step in order to get one step closer to the braiding machinery.
We're going to unwrap it and wrap it again.
Absolutely.
Martin, this material looks familiar. We saw this being knitted on the machines earlier. What's happening here?
Yeah, unfortunately, we can't process the material like this on the braiding machinery. So we have to do a rewinding process again in order to get it on the carriers for the braiding machinery.
That's great. For some reason, I just like the way it looks. It looks kind of silly to me. And check this out, everybody. I've got a new neck gaiter, huh? Let's see. What do you think? Does that look good on me?
Awesome.
I think that this could potentially be, you know, a fun like swag product for you guys. You mentioned that you do upcycle some of the pieces that are too short, but some like this are too short for anything, correct?
Yeah, true. Some are too short, but as mentioned, we're trying to use almost all the material due to financial and for sure eco reasons. And this is where the Boa Eco, for example, is coming from. So if we rewind the material, all the bobbins we're using, or the carriers on the braiding machine, has to be the same length. So if we would create one carrier being less long, then the machinery would stop, and we had to chunk away all the other carriers, which is no sense at all. So what we're doing, if we have left over here, which is long enough to create a bobbin or a carrier for the braiding machinery, but not as long as the normal production length, we are using this material in order to set up the Boa Eco. So these are carriers with different lengths, then we're trying to cluster them in weight. And so this is why the rope does look different all the time, because we're using all the leftover material to set up the carriers, and then all these leftover carriers are put onto the braiding machinery in order to create the Boa Eco.
The only question I have is whether Blair is going to call this the EDELRID Echo Gator or the Boa Gator, or the Boa, or the Echo Scarf. Ooh, I like that, Blair. Echo Scarf or Echo Gator? I think Echo Gator because it goes with Boa, right?
That sounds good to me.
The Echo Gator from EDELRID, coming to a store near you soon. Martin, what's the next step after we've unknitted these materials?
Sure.
Let's take a look at the machine over here. So we're on the other side here, and we see these are actually being unknitted and then wrapped onto the bobbins?
Yeah. So a braiding machinery is mostly defined by the number of carriers running around. So, and the most used machinery at our facility is 40 carrier machines. So 20 carriers running clockwise and 20 running anti-clockwise. And this is the carrier. We are putting the sheath material onto it. So roughly, if we talking about one production run, this would be around 1,500 meters of sheath material, which is creating 1,000 meters roughly of rope at the end of the day due to the angle of braiding. This is the production run length is a little shorter than the material we put in onto the carrier.
I noticed that some of the bobbins are red and some of the bobbins are white. Is that to signify the difference between the S and the Z twist?
Absolutely, that's it. So we have to twist the material one time clockwise and anti-clockwise, depending on the way it's running around the braiding machinery. And yeah, the color does differentiate the twisting direction of the yarn.
And this machine, it only does red bobbins, and this machine only does white bobbins, it looks like.
Currently, it's the way it is, but it can be set up different as well. Yeah.
Great. All right. Well, thank you for sharing this stage in the rope manufacturing with us. What is the next step after this?
Yeah, next step, we finally made it to the braiding machinery, but this is done downstairs.
To see how the braiding process works, check out another video on our YouTube channel where we have the entire EDELRID rope process extremely well documented. Martin, thank you so much.
No worries.
Very cool.